Hi students, welcome back. Let's continue with this theory of computation, finite automata. In the previous video, I explained about the DFA and the different examples on the DFA. Now let's coming to the next type of finite automata without output, that is NFA, non-deterministic finite automata. You can call it as NFA or NDFA. Both are the same. Non-deterministic finite automata or NFA, non-deterministic finite automata. So the finite automata are called non-deterministic finite automata when there exist many paths for specific input from the current state to the next state. So did you observe the difference between NFA and DFA here? In DFA, there exists only one path for specific input from current state to another state. Suppose if 0 is there, the 0 can go to only one state, not twice. Okay, but in this NFA, there is many specific paths. Many paths for specific input from the current state to the next state. Okay. So many paths for specific input. Suppose 0 is there, the 0 can goes to many paths. Either it can go to the state A, or it can go to the state B, or it can goes to the state E. Suppose it is coming from X. The 0 state the input can goes to any number of states. Means so many paths are there. Okay. So here in this, the main difference here, the NFA and DFA is, in the DFA only the specific input can goes to the specific only to the one path, but here the many paths can exist for the one specific input. And it is easy to construct NFA than DFA for a given regular language. If any language is given, to construct NFA is very easy when compared to the DFA. Every NFA is not DFA. Remember that. Every NFA is not DFA. Why it is not DFA? Because DFA is having only one path for specific input. Whereas NFA is having many paths for specific input. So every NFA is not DFA because NFA is having multiple paths. The multiple paths are not accepted by the DFA. But each NFA can be translated to DFA. But you can take one path and you can translate that path to DFA. Is it possible? Right. Because you just take this path and construct, this is an NFA. You can take this path and this is DFA. Okay. And you can take this path and this is DFA. And you can take this path, any one path, it is DFA. So, NFA can be translated to DFA, but every NFA is not DFA. Remember that point. So, NFA is defined in the same way as DFA, but with two exceptions. So, what are the two exceptions? It contains multiple next states. So, for each input, there are multiple next states are there. And it contains epsilon transition also. In NFA, the epsilon transitions is possible, whereas in DFA, there are no epsilon transition. So that I'll explain in the next video what is this epsilon transition. Now let's talk about this multiple states part. This, I said, it contains two exceptions. It contains multiple next states. So here you can see this is an NFA. How can I say this is NFA? Because here the same input, specific input has multiple paths. How? So here Q0 on A goes to Q1 and the Q0 on A goes to Q2 also. Multiple next states are there. Okay. The Q0 on A goes to Q1 as well. It goes to Q2. So these are multiple next states. So whenever you see in the diagram, you can easily understand is it DFA or NFA. So DFA, you don't have the multiple states. Okay, only one symbol can goes to one state only. It doesn't goes to the multiple states. The same symbol, specific input, cannot contain the multiple states. Only one state should be there. One specific path should be there in the DFA. But in NFA, you can have the multiple states. Okay, so the Q0 for input A, there are two next states, Q1 and Q2. Okay, similarly, the Q0 on B. Okay, the Q0 on B goes to the next state to Q0 as well as to the Q1. So, thus it is not fixed or deterministic. So, with a particular input where to go to the next state. So, hence finite automata is called, we call it as a non-deterministic finite automata. Okay. So because it is not fixed, Okay, specific path is not fixed. There are multiple paths. Suppose this path is not suited, it is not reaching the destination, you can select the another path. Okay, suppose if first I had taken this path, Q0 on A goes to Q2. So here from Q2 I'm not going to anywhere. I'm just moving to the phi epsilon. So I can select this path. Q0 on A goes to Q1. Reaching the final state, I'll accept this string. Okay, these are the multiple paths are there. So in that multiple paths, you can select any one of the path. So this is the main advantage of using this NFA. I am having the multiple paths. I can select any path. But in DFA, there is no multiple paths. Either you can accept or you can reject. So in this NFA, you can take the multiple paths. From that multiple path, select one of the best path and which is going to be accepted and which is going to reach the final state. That string I can accept. That path I can choose. So that is the main disadvantage of using NFA. So you will get a doubt why I'm going to use NFA if DFA is there, because DFA is fixed. In some situations the DFA will be used, but in some situation NFA will be used, because here the backtracking is there. And suppose if you want to move from if you want to anyhow you want to reach to the final state, means you can select the multiple paths. So in some situation there is a way of selecting the multiple paths. In that cases we will use this NFA. So I hope you understand clearly what is the difference between the NFA and DFA. NFA is having only the single path which leads to the next state, whereas in NFA it contains a multiple next paths. Let's see the formal definition of NFA. NFA also have the 5 states same as the DFA. So it's just having the 5 tuples just as a DFA, but with a different transition function. So what is the different transition function? This is the transition function. Whereas DFA transition function is delta is equal to Q into sigma. That is the current state into current state input symbol leads to the next state. Okay, but here in NFA, the current state with input symbol leads to multiple states. So that's why it is 2 power Q. Multiple states you will get. Multiple states. That's the main difference between the NFA and DFA. The transition function will be different. Here it gives to only single path, but here you can get the multiple states. That's why it is taking 2 power Q. Multiple states. Q is the finite set of states. Sigma is finite set of input symbol. Q0 is the initial state, F is the final state, and delta is the transition function. So this is the definition of delta. Q into sigma leads to the 2 power Q. So this is the formal definition of NFA. Now let's see the graphical representation of an NFA. An NFA can be represented by diagrams. Diagrams means directed points. So this is the directed point, called a state diagram. The state is represented by a vertices. So this is the state which is represented by a vertices. Okay. The arc labeled with an input character shows the transition. So here arc which is showing to the input symbol is a transition. You call it as a transition by taking the input. The initial state is marked with an arrow and the final state is marked with a double circle. So just like a DFA. Thank you.